The last kind of transformation in terms of compressions and function notation is compressions and stretches. So we want to focus on the question of what's being changed. Is it the output that's being changed, or it's the input? Is it X or is it Y? Again, we'll start with our basic equals X squared. What happens if you double X? We're multiplying the output by, and what happens if you half? Again, changing is being changed. What happens here is you end up with what we'll call a stretch. Maybe a better way to think about the change of height at inputs. So if graphically f of x equals x squared, if it looks something like this, and then doubling f of x is going to stretch that whole thing up. It'll make it taller. Because what's happened is that the outputs have been doubled. And if again the exact same problem. C times f of x greater than 1. Get a vertical wedge taller. And if C less than 1, get a vertical stretch shorter. And that should make some sense because what's been affected are the outputs. F of x over y has been doubled, f of x over y has been multiplied by 1/2. Now, in a different sense, if we were to double the inputs, notice that our resultant expression is different. So although graphically it may look the same, we have to understand it's doing something different. Or if we were to half the inputs, end up with something slightly different. And the way we're describing the stretches, we'll call this a compression. And this really has to do with, say, width. If we have our graph of x squared looking something like this, then if we double the input, it does look like it's gotten taller. But since what's happened is the input has changed, the graph has gotten skinnier because our change has been horizontally. And if we half the input, something like that, and it does look the same as getting shorter, but really the change has been horizontal, so it's gotten fatter, wider. So Notice the difference, the changes to the input as opposed to the output. If C is greater than 1, a horizontal stretch, compression, the graph is linear because the change has been horizontal to the inputs. And if C less than 1, then a horizontal stretch. Fatter, wider. It looks the same, but what's being changed is really what's different about it. Inputs are being changed, outputs are being changed. When inputs are changed, it's a and outputs are being changed, it's